So this presentation is a State of GeoServer 2.12, is a summary of the new features in GeoServer 2.12, which is going to be released in September. So in a month, we are about to release the beta, and in a month we will release the stable. Unlike all the other presentations in this morning, which were focused on a particular topic, this one is going to jump around a lot, discovering all the new features that we are going to push in GeoServer 2.12, and then we can have a discussion at the end about complex features, 3D and the like. So, first, a quick overview about GeoServer in 2017. What happened? Well, I assume you already know what GeoServer is. This slide cites all the OGC protocols GeoServer implements. The usual: map viewing, map editing, raw data downloading, vector raster format, processing, catalogs, and tiles. Nothing new there. Project status. The developer team is growing, although as most open source projects, you will find that a handful of people are actually doing most of the work, like 5 to 10 people. This happens in GeoServer, but it happens pretty much everywhere else. Look at MapServer, look at QGIS. Every big project has a small group of people that are doing the bulk of the work, and then a long tail of other people that are contributing extras. If you look at the user list, we are down from 2,000 people to 1,400. This is not a bad thing per se. SUS4 just sent an email to everybody that was subscribed to the list, asking them to confirm that they wanted to stay on the list. I think that having 1,400 people confirm that they wanted to stay there is a good thing. It means that many people think the list is relevant and useful. The release schedule continues to follow the usual 6-month time box model. So we make major release in September and one in March, and then every month we make bug fix releases. We have a stable series and a maintenance series and a development series. So now 2.12 is development, is about to become stable. 2.11 is now stable, is about to become maintenance, and 2.10 is going to be thrown out of the door, not maintained anymore. We had some little trouble with the user list participation this year because not enough people are answering questions. Many people are making questions, that for sure, but not enough are answering them. So we are asking everybody on the list to read a couple of presentations about how to behave on a user list, on how to make intelligent questions and effective questions. And we have been asking developers to be more active on the list as well. At the same time, every last Friday of the month, all the developers group in a bug stomp day, in which we try to kill as many bugs as possible. Which is, well, one way to keep the project open, because many people are reporting issues, but most of the developers are busy in their commercial work day to day. During that day, we fix issues that are not part of our commercial activities. And the rest of the month, we also fix bugs, but for our customers. GeoServer is starting to be an old project, and we have a number of old libraries inside. In February, we had to replace one of these old libraries with a newer one because of maintenance, and we had a large participation of people from GeoSolutions, which hosted the event in his offices in Viareggio, Italy. From Boundless, especially the group from Victoria, Canada, and from Aston, which is from UK. Yeah, an example of the documentation that we generated along with the new code which has been migrated, a group photo of the people that participated, and this is not something that generated new functionality. is about making GeoServer more future-proof by using newer and more stable and better libraries. So, going to what is new, we have categorized the novelties by topics. So, new vector data sources. GeoPackage, it says community here because it used to be a community module. Community modules are new modules which are not maintained officially. Well, now GeoPackage is becoming a core module for given the importance of this format as a replacement for shapefile, as a OGC well-supported format for both vector and raster data. We decided to make an extra effort and push it directly into core. I have merged the pull request that puts GeoPackage into core this morning when the plane landed in Seoul. We were waiting for the gate to be freed by another plane. The pull request is green, let's merge it and move on. In the community area, we have a new GeoJSON store which allows GeoServer to directly read the GeoJSON files. It's not meant to be used for high-performance setups. GeoJSON is, after all, a text-based format, but it can be useful if you want to render small GeoJSON files. Similarly, we also have now a CSV store, which has been improved to the point that it is actually useful. It has been there for a while, but it was an example for programmers. You know, it was training wheels on how to build a new store. It has been improved to the point that it's actually useful. Same reasoning as before, useful only for small files. And we also have improved the CSV so that it can be used as an input and an output in WPS processes. The code base is the same, it's used in different ways in the two cases. In terms of raster data and raster processing, we have been working very hard on improving GeoServer to handle image mosaics made of several images in different coordinate reference systems. In particular, in one of the projects that I'm working on, we are targeting at making a global mosaic of all the Copernicus images, so Sentinel-1 and Sentinel-2, which are coming in all UTM zones. So we are talking about 120 different coordinate reference systems, plus the 2 UPSs. And we don't want to reproject them into one single coordinate reference system, but keep them as is, just to have faster ingestion. Otherwise, we would have to transform a format, warp it to a common coordinate reference system, retile, and so on. No, we want to keep the data as it comes from Copernicus. So we are trying to handle a single giant mosaic of images with a deep temporal depth in a single shot, and with images crossing the dateline. Copernicus, well, the satellites take images that unfortunately cross the dateline. They are part before, part after, and when you are projecting that, fireworks start. It's a really difficult problem. It took me a few days to crack it. We have been improving reprojection handling for scientific data. There used to be some border effects that are now gone in GeoServer 2.11. And on the same topic, we have been improving interpolation when no data is present in your source data. The before and after shows what happened when at the border, basically no data was being interpolated along with the good data and it was taking it down to, because typically no data is the lowest negative value that you can pick in your dataset. So we have also resolved that one. If you are into multidimensional data, there has been several improvements in the NetCDF reader. NetCDF is a multidimensional raster format which is used a lot in the weather forecast and the like, science in general. It can represent raster data in 4 or 5 dimensions, depending on what you want, or what you need. So We have made several improvements into that. If you have tried an SCDF in the past and it wasn't good enough, I suggest you give it a try again. There is some push to go towards the cloud. There is a new community module in GeoTools which is being merged, which allows to store TIFF files directly in a S3 bucket, and GeoServer will render them as they are. It's a starting point. I don't think it's going to be great as is. It's a way to store a TIFF in a S3 bucket. It's still not fast, because as S3 itself is not fast. We have to find ways to reorganize the data to compensate for some S3 limitations. We have ideas, we love planting. If you're interested, let us know. In terms of styling, what's new in GeoServer? So in GeoServer 2.10, we improved the style editor so that you can edit a style and preview the map at the same time. It used to be that you could edit the style, but then you would have to go to another page to view the result. Now it's a single page doing the editing and the previewing for all supported languages. So SLD, CSS, YSLD, and the Mapbox GL styles. There are a bunch of new features in the CSS styling language. The CSS styling language is a CSS-derived language which is still compatible with SLD. So we basically turn it into SLD on the fly. In 2.10 we added support for rendering transformation. That is, for example, the ability to extract the contours on the fly from a raster map and then render the contours. We added the ability to nest the rules to get a more compact representation of the styles, like in SAS, for example, or pick your CSS preprocessor of choice, less SAS those. In 2.12, we added the code completion in the editors. It's a modest one, but it's useful if you don't remember the property names. Now in the web page you can code complete the properties. We have less CSS compatible color functions, so you can take a color and make it darker, lighter, saturate, desaturate, and so on. We modified the scale denominator rules to make them more compact and more readable. With scale denominators, you never know by just looking at the number if it's 100,000, 1 million, 10 million, because there are too many zeros. But if you read 100K, 1M, then it's evident. We improved a lot the speed of translation between CSS and SLD. I've been playing with OpenStreetMap like symbology, which can be like 700 lines of CSS and 5,000 lines of SLD once translated. It used to take a lot of time to convert, now it's fast. So, quite a bit of work on the CSS side. It's stuff that I've been doing in my spare time during the past few months. At the same time, Boundless has been busy with two other languages, YSLD, which has become supported. YSLD is basically SLD in a YAML source. YAML is a different way to represent XML without using tags, but using spaces and indentation instead. So you get a more compact representation of the very same concept. So basically what you see there is a one-to-one representation. It has a one-to-one relationship to an equivalent XML document, but it's more compact and more readable. And at the same time, Boundless has been busy implementing the new Mapbox style specification, which is JavaScript based instead, actually JSON based. Which is interesting if you are using vector tiles, because using this language you can get the same rendering server side and client side. So you want to support OGC protocols, and to the latter you use server side rendering and raster tiles in output. If you wanted to become more, let's say, GeoHipster compliant or more modern if you want, and less OGC compliant, you can use it client side and use vector files instead. There have been several improvements in the labeling subsystem, partly because of my work on OpenStreetMap, partly because of some work that I've been doing on QGIS, compatibility between QGIS and GeoServer. So we now support underline and strike through. We can control character and word spacing in the labels. And it's now possible to label the borders of a polygon instead of its centroid. And finally, perpendicular offset is supported for curved labels as well. Before, you could only place a curved label on top of a line but not offset it. Going to the QGIS compatibility, there has been some effort during the last year to make it possible to generate a project and a style in QGIS and then export it to GeoServer. It used to be there, but there were so many issues that the style was not actually going through properly. I have been doing some work last year and also during the last few months to improve this situation. In particular, for example, in QGIS 3 you will be able to finally export labeling from QGIS to GeoServer. It used to be completely missing. When you were exporting an SLD style from QGIS, the labels were there. In QGIS 3, they will be exported, and GeoServer will represent them in a similar fashion. Labeling engine is a complex beast. You cannot pretend to get the exact same label positions, but it's going to be close enough. Moving on, what's new in WebMap service? We have the vector tiles extension, which was a community module, and now it's an officially supported module. So vector tiles have been covered by a previous presentation already, so I'm not going to repeat what has already been said. Let's say this ability of GeoServer to generate vector tiles is also known as a map box without a map box. Because you can do what they do without their servers, but using your own. And if you are using the map box styles, you can get consistent styling server side and client side. We have been improving the centroid and label placement in vector outputs, where by vector output we mean vector tiles and KML. We used to have an issue with polygons in which the centroid, the center of gravity, is outside of the polygon because, well, look at this one, C-base, it looks like a capital C. Its centroid is outside of the polygon, so we improved the labeling algorithm, the centroid extraction algorithm, so that the label actually stays inside the polygon. We have been working on WMS, and I'm going to go back to it, but also on WCS, with a new sort of I parameter. It's a vendor parameter. The WMS specification has no notion of sorting, but we have implemented this new functionality in GeoServer. It works for vector data, sorting a particular attribute, nothing new there, but it's interesting because it also works on image mosaics. Image mosaics are made of many tiles, and you can attach attributes to them. So you can sort on a particular attribute attached to a tile. So for example, these two images are coming from exactly the same image mosaic, but in one I've sorted by cloud cover to have the least cloud cover possible, and in the other instead I've sorted by recency to have the most recent image possible on top. And of course you get different results. For scientific data, we have been working on extension that allows GeoServer to play better with scientific data. There used to be an animation, but of course it doesn't show up in the PDF. What you can do with these NCWMS extensions, well, you can give a GeoServer a palette of colors and then say, okay, linearly interpolate between the minimum and maximum value of this layer, and I want to give you the values. Or linearly interpolate between these two values that I'm giving to you, so that I can highlight a particular subset of the data. And I can also apply logarithmic scale versus linear scale. So the animation would have made it evident, but anyways, it's a way to quickly display scientific data, in particular NetCDFs. We have some news on the WFS side as well. GeoServer has had a long-standing issue which was happening sort of randomly, where there was actually a way to make it happen predictably, but most people were not hitting it, luckily. I'm not sure if anyone has ever hit it. Sometimes in the WFS output in the GML you got this null prefix which was breaking GML conformance, of course. And the only way to get out of it was to restart the server, which was very, very annoying, and it has been fixed. Anyone here has ever hit this issue? Null prefix in GML output? No? Okay, good. AppSchema is the store that does complex features. So before I heard mentioning of CityGML. CityGML is an application schema. Complex features. The AppSchema store has seen several improvements from the performance point of view, and now it can also use a MongoDB data source instead of a relational database in case you are into NoSQL databases. Now you can hook them up into AppSchema, and there's this Hail application, which is a desktop program that you can use to go from the relational database structure to the application schema, the GML application schema, and basically draw the connections. It has also been improved to support MongoDB. Also, in terms of complex features, GML is nice, but not everybody likes it. Not everybody agrees on its usage. In GeoServer 2.12, we also have the ability to go out with the complex features in GeoJSON representation instead. So we can have features that have nested features, list of features inside of them, and so on. Basically a complex tree of information instead of a usual flat table representation. Going to WCS, the raster product of the WFS, we have what I was talking about before, the ability to sort again. We added it as a vendor extension to WCS as well, so that you can basically first look at a map with the WMS, sort it the way you want, and then use WCS to download the original data, the raster data, the raw data behind it. NetCDF has been also improved in WCS. In WCS, NetCDF can be an input, but it can also be an output. So, say you have a multidimensional raster dataset and you want to extract a 4-dimensional cube of data. NetCDF is basically the only output format that we have nowadays that can extract a cube of a certain area, certain elevation plus time, which would be a 4-dimensional cube. And there has been several improvements in terms of keeping metadata which is in the input and make it available also in the output. Tiling. What's going on with tiling in GeoServer 2.12? Well, there are several news as well. We have WMTS cascading. GeoServer already has had for several years WMS cascading, the ability to talk to another WMS and provide it in output. We had WFS cascading. In GeoServer 2.12 we are going to add WMTS cascading, so the ability to read the types from another server and make them available as WMS if I want, or propose them again as WMTS. This slide is a bit complicated. Let me summarize it quickly. In WMTS, you can have several parameters in the request. Basically, every time you change a parameter, you are generating a new tile cache. Say you have a SQL filter. A SQL filter allows you to filter which features appear in a map. Every time I change the SQL filter, I'm making a new map. I'm making a new tile cache. The ability to drop all the tile caches associated to the various parameter combinations was a bit weak, and it has been fixed in GeoServer 2.12. This one I'm going to skip because I think I'm starting to be a bit late, right? Okay. So, what's new in terms of configuration and management? In GeoServer 2.11, we disabled by default the ability to do WFST because people were kept on forgetting to disable it. Basically, people installed the GeoServer out of the box, which is a demo installation, which was meant to showcase WFST, and people forgot to disable transaction. And they went online with the people being able to just edit data, which is not right. So we basically limited by default, only the administrator can edit data. We improved significantly the startup times on large data directories. That is, when you have, let's say, 10,000 layers, 20,000 layers, it used to take several minutes, and well, now it's significantly faster, which is GeoServer 2.11 and newer. In those cases, when you have lots of layers, we did not just make the startup time faster. Also, the OGC request time improved a lot. So if you are making a get map, it's also going to be significantly faster compared to before if you have 10,000 layers or 100,000 layers. We improved a lot the EPSG code lookups. It's probably common experience. You throw a shapefile as GeoServer, and GeoServer says, well, okay, but I don't know what EPSG code to use for this. In GeoServer 2.11, the lookup has been improved both in terms of performance and accuracy. So you should hit that I don't know what this is a lot less than before. I'm going to skip a few bits because there is too many slides. In terms of configuration, we added the ability to parameterize some configuration elements so that you can have variables outside of GeoServer telling it where to connect to a particular database and so on. This solves a typical case of having several environments. I have a test environment, I have a production environment, I have a developer environment, and they have each one that has their own databases and their own LDAP server and so on. Now you can stick variables and keep the same data directory across all the environments, and you just replace the variables. There is a new backup and restore community module, which allows you to do a full backup of a configuration and then restore it in a different environment. Finally, in terms of security, there is a new OAuth community module which allows you to use this authentication protocol also in GeoServer. So there are a few examples. The important one is GeoNode. GeoNode is the software that has been promoting this development. But there are also examples on how to log in GeoServer using your Google account or your GitHub account. Right. So we are getting periodically security fixes in GeoServer, and we are implementing the fixes in the stable and maintenance version of GeoServer. There are way too many old GeoServer around on the web which are not getting the security patches. So please, if you are managing a GeoServer, remember to upgrade it once a year, if you can. Looking ahead, what's going to happen in the next few months? Well, first off, Java 9 compatibility. Towards the end of the year, Oracle will release Java 9. it will be the first release in many years that will break backwards compatibility. So if a program runs on Java 8, there's no guarantee that it will run on Java 9. And I guarantee you, GeoServer as it is today does not run on Java 9. Because they broke our plugin system. So we have to make a few changes in GeoServer to make it run with Java 9. And this is, of course, on the menu for the next few months. And the other thing is under the Java Advanced Images, which is the library that we use to do all the raster processing. It's great, but it's really old, and it has a strange license. One that says, yeah, you can use this, but not in a nuclear facility. I don't think that anybody's going to use GeoServer in a nuclear facility, but still. We are trying to gather funding to rewrite it from scratch. And yes, that's it.
Andrea? 그 질문은 저희가 끝나면서 밖에서 하셔야 될 것 같아요. 이게 1시부터 또 다른 컨퍼런스가 바로 진행이 된다고 해서